analyst. What growth trends do you foresee for the adoption rate of liquid cooling in the coming next 3 to 5 years?
It is like you are asking a crystal ball kind of a question, correct?
Yes.
So, coming from India, we should ask that, okay, please give us the patrika of when the liquid cooling technologies were developed. We'll have to see some horoscopes to predict when and what will happen. But on the
Yes.
more serious note, there are information which are available with reports where the analysts believe that within the next 5 years, close to 40% of the data center loads will be liquid cooled. That is the trend that we are looking at. Today, it is less than 10%. So with less than 10% going to 40% only liquid cool is some of the trends. Now, why are these trends believable? Because there needs to be some logic behind it, correct? So one of the themes that is really going to drive this adoption is going to be the adoption of more and more hardware for AI applications. GPUs are already very, very highly dense and energy consuming devices. So last year when H100 was launched, it was with SXM at 700 watt per chip. Blackwell is already 1500 watt. And every year we are seeing some new GPUs being launched, maybe multiple times a year. So that is also because another fact, the technology of chip development itself has transformed. To quickly give an answer why I'm saying so, earlier it was a single die design. A new chip means right from scratch you build the design the complete chip. That is how the design process was because the entire chip was supposed to be one die. Today with the Blackwell 200, which is something that even the NVIDIA CEO mentioned when he presented and launched the Blackwell 200, they are fusing dies together. So they make two dies and they fuse them together to make a larger die. The two dies are developed independently, right? So it becomes like modularity in chip design. Now, to make it more complicated, there are technologies that Intel had already launched 5 years back, where they are doing layered chip design, like a sandwich, right? So it is not just a single die and a single chip, it is in two dimensions. You can make it bigger and thicker. And that is how the chip design is transformed. And by making it modular, from a typical development cycle of a chip, which used to be as high as 3 to 4 years, today it is less than a year. And that is why you see H100 got launched, less than 12 months. B200 is launched. Another less than 12 months, I'm sure something new will be launched, and so on and so forth. So the frequency with which these chips are becoming denser is becoming very, very high. Now you combine that with the IT refresh cycle. Typically, between 3 to 5 years, people develop and deploy new IT hardware. So if data centers are going to be designed today, they already need to start thinking about how their data center will last for the next 5 years, unless they are going the liquid cooling way. Now, which liquid cooling way? Any liquid cooling which works for the customer is a good technology. That is my belief, right? Because liquid cooling itself is a nascent stage right now. Not many mature technologies exist, but only with deployments at customer places, by looking at the experiences, sharing that experiences in various forums, that is how the general knowledge about that technology becomes more common, and customers start congregating towards one particular technology which may be applicable for a particular type of an application or a particular type of an environment. And that is how I would expect the liquid cooling platforms to become more mature going forward. Whatever works well for the customer is a good technology, right? At the end of the day.
Yes. Thank you very much for sharing that perspective. Uh,
Gopal, if I can
Vijay,
add to the
yeah,
fantastic answer
please.
which Amod said, on a more on a lighter note,
Mhm.
this is the second webinar I'm attending today presenting on liquid cooling. So at
Oh,
least the awareness is growing significantly in this part of the world. Ignore the rest of the world, at least in India. The awareness is significantly increasing in terms of liquid cooling. And I can humbly say, when I joined ZutaCore, I had to introduce liquid cooling, introduce ZutaCore, introduce dual phase. We've crossed the stage of liquid cooling. People are no more asking why liquid cooling. And I at least get one new call a day from unknown number. asking about ZutaCore, which is, are they buying every day? Are they waiting outside my door? No, no, they're not. But we are still a long way from there. But at least the awareness, the eagerness to learn on why we should deploy, at least they want me to convince them on why I should deploy. So that's a far jump from 18 months before where India was in terms of liquid cooling. So there are questions coming, not just from the usual suspects, the colos and the DZs, even captive DZs now started reaching out. Education institutions in a big way have started to reach out. Indian server manufacturers are starting to reach out. In fact, there is a GTC NVIDIA event. So there's a lot of noise around that. I'm sure all of us are aware of that. So there's a lot of noise around, why liquid cooling. As I said, are they waiting with POs outside the door? No, but at least the conversations are now more than what it was 18 months before.
Don't worry, Sampathji. Just to give you an analogy, 5 years ago, none of us thought that somebody will be delivering food at our home, and
Absolutely,
5 years
Vishal.
later,
Absolutely.
the company is listed in the stock exchange with such a large market cap. So
Seriously.
that's how the transitions are. So
I know,
no wonder
absolutely.
I won't be surprised if that kind of transition is into liquid cooling. I'm sure it will be,
We'll all win together. We'll make a sustainable world together.
certainly.
Sorry, Gopal. I thought I should add to
So
that. Yes.
yeah, that's good. So AI is also there. That is also coming in a big way to troubleshoot all the problems.
That's right.
So yeah, Mr. Vishal, so what are your views about liquid cooling taking shape in the coming times?
Yes. So again, to extend this analogy, that all these everyone be food delivery apps. So whatever and anything and everything that has access to internet is contributing to the data center. And then again, a few years ago, we had this air cooled and those topics to discuss, because um, uh, rack density was much lower. Such a servers were not available. And then now we are sitting in the world where we are talking about 30 kilowatt, 40 kilowatt, or up to 80 kilowatt load on the rack. Maybe just to bring the tangibility to it, one microwave oven we have at home is about 1 or 2 kilowatts. So let's say 28 liters microwave oven is at 2 kilowatt. So we are talking about 40 such microwave ovens in one single rack. Imagine the heat it is dissipating. And uh, as Amod also said, and Sampathji also said, that air cool is out of question. That's not the capacity of air as a media has to dissipate that heat. So there has to be an answer, and the answer, or most viable answer right now, is liquid cooling. So be it be next 2 years, 3 years, 5 years, 10 years, whatever. I personally see this is something which is going to be a future. Of course, it will remain in conjunction with the air cooled, because imagine racks, and those racks are dissipating heat. Again, there has to be a media which will collect that heat. But yes, when it comes to direct to chip cooling or rear door heat exchanger, this liquid cooling is the answer right now.
Thank you very much for sharing your views. Mr. Vijay, coming to you, you are talking about the waterless liquid cooling for sustainable AI, and you want to eliminate the emissions also.
That's right.
So, how does liquid cooling technology help manage increasing heat density of the coming data centers with HPC and AI workloads?
Good question, Gopal. So we use, when we say waterless, we're talking about the secondary cooling. And we want, primary, it's a different connotation, which I'll extend after this. Okay. Inside the rack, we don't want to have any water which is getting inside the rack. Why? Pure nature of the water by itself is bad for the servers. Water doesn't choose servers or human, it's the same. It doesn't change the nature. So we are against the corrosion or combustion of any of the servers. So what we use is a dielectric liquid, which is helping to optimize the performance of the servers. Like extending what Amod said sometime before, because of direct to chip or any immersion liquid cooling, we remove the fans inside the servers. There's a direct saving of power immediately. So because we're able to remove all the fans inside the servers, we're able to have more power utilized for the compute. So let's take 10 steps backward. What is the primary objective of a data center? It's not to showcase your power skill or your real estate skill or cooling skill. It's for compute. Compute happens inside a server, nowhere else. Okay. So what we are giving is a more denser racks, okay, which can help you to give more compute power. And the compute power also is more primarily because we are direct to chip, we're able to absorb 100% of the heat. There is no latency in heat removal. Okay. So we are top of the CPU, GPU. We remove the fans. Matlab, there is no fans, no power consumption by the fans. So that percentage, roughly around 15% of the 15% of your server power goes to again densifying the racks. So that is why we're able to use that from a rack density perspective. When we say waterless, what we want, where we aspire as a company, ZutaCore, when we say sustainable AI, when the primary cooling is water for denser racks, what we are recommending is you can have primary cooling as dielectric also, where there is zero water involvement inside the data center. So no water involved, no treated water. For example, we know a lot of companies use treated glycol. What is glycol? It's nothing but a treated water. So there is no glycol. It is just dielectric liquid, which can be a primary too. So that way, what happens? You actually get a green data center. No water used at all. Now, that's what we are
So,
aspiring. Are we ready as a country or even as a planet? I'll probably say 1 out of 1,000 DCs are talking to us about a complete DC. Like what Vishal said, nobody thought food will be delivered at your home. As we are talking, I ordered something for my son too. So he's already eating. So Vishal, I was reiterating what you're saying. So probably that be the day come when everybody wants primary also as dielectric, but it's sooner the better for all of us. The next generation will have more water to drink than buy.
so while you talk about the dielectric fluids, what's the chemical compositions?
I'm not able to reveal too much on that. It's a lot of,
Right.
just leave that part of it alone with us.
Okay,
So,
okay.
Gopal, I'll just add to it. So,
Yes.
typically, it is a class of liquids, right? So, when we talk about liquid immersion cooling systems,
Mhm.
all the coolants that we use are hydrocarbons. They are
Okay.
all artificial hydrocarbons. So, there are technologies where you can derive it from oil, or you can also synthesize it from gases. So, there are some of our partners who manufacture with a technology called GTL, or gas to liquid. So there are hydrocarbon chains of different types as far as liquid immersion single phase is concerned. The moment we start talking about two phase, a very simplistic way to describe is there are different types of refrigerants. Because basically what is a refrigerant? It is a medium which can transform into two particular states. And by using the latent heat, they are more efficient in capturing the heat. So, but because we want the properties to be slightly different, so there will be different variants of refrigerants typically. So most of the two-phase systems that I'm seeing out in the market, their coolant is a type of a refrigerant.
So it's sort of PCM you are using.
Can you say that again?
Sort of phase changing materials you are using.
That is correct. So that's why I'm calling it a refrigerant, because most of the refrigerants by design have to operate in two phases. So in the evaporator unit, you convert it from liquid to gas, and the condenser unit, you condense it back to liquid. That's how the refrigeration cycle works. So typically, whenever we say two phase, largely it is between liquid and gas state that we transform.
Mr. Amod, so you were talking about the air as an insulator. It's a bad conductor of heat. And while we are going to eliminate the heat from the data centers, so how do you address the challenges faced by data center for implementing this cooling technology? Is it sort of a retrofit
So
or
there are
sort of hybrids?
there are multiple scenarios that we are seeing with respect to the interest. The first thing I would like to be very candid and share with the audience who are looking at a different technology today, right? So
Right.
only those customers who have had a bad experience from air cooling are the ones who are looking for something different, because all customers never try to solve a problem which doesn't exist, right? So unless they have had an experience that, oh, I'm not able to handle high density, I'm having some downtime, there is a reliability problem on the IT output, that is when they start looking at a different technology. So today we are very clearly seeing that 4 application areas are where customers are really challenged by density and air cooling. So which are these areas? High performance computing, high frequency trading, cloud deployments, and AI clusters. These architectures by design require very high density, right? And that is where the first challenges are coming. The second wave will happen where the server OEMs themselves will say that no, for my server, air cooling is not an option. So the customers have no option but to start looking at a liquid cooling kind of a solution. So right now you are seeing in the market, a lot of server OEMs have started launching servers which are designed from the factory either for direct liquid to chip or for immersion. They are designed like that. So that server you cannot use in an air-cooled environment even if you want to. So going forward, there will be definitely a design criteria by the IT OEMs that will drive adoption. Until that happens, it will be experiences of downtime that will drive adoption. And lastly, how difficult a particular technology is it's never going to be a single answer, right? I'm not trying to be diplomatic. I'm also not trying to just claim that the liquid immersion single phase is the best because I'm from GRC. Very candidly, I'm saying every technology comes with a trade-off, right? So it is going to be very interesting to see how customers deploy different technologies and they see whether the trade-off works in their favor or not, right? For example, if you are going to see the movement of data center design over the last so many years in our part of the world, an uptime tier 3 plus is the most appropriate or most acceptable tier design, which people do. They may or may not get it certified, but the design is concurrently maintainable. Now, different cooling technologies have different takes on how concurrently maintainable the system really is. And that is where the trade-off comes in. The customer will say, okay, I'm okay if it is not concurrently maintainable, but it is solving some other problem. Somebody will have a space problem. He will say, I don't like liquid immersion. You're taking more space. Somebody has an efficiency problem. He'll say, okay, I'm good with liquid immersion because I can use chiller free and get a PU of 1.1. Somebody will say, I don't really like the touch of that coolant in the immersion where it is like oily. I don't like it, right? So somebody will say that I don't like refrigerant because it is more expensive. So there are always going to be technology trade-offs. And that is why I feel we are living in the most interesting part of this technology adoption of liquid cooling, where different technologies will get deployed in different data centers. And a lot of customers will look at these trade-offs and slowly they will evolve in what will be a more acceptable or more popular kind of a technology.
Thank you very much for the insights you have given. It is dependent upon the design also.
Yes.
And like Mr. Vijay Sampath was telling, spreading of awareness is very necessary. So, Mr. Vijay, what challenges do you see in adoption of liquid technology?
Like I'm going to resonate what Amod said. They are not coming to us because they love us, but because they already have a challenge. If they have a challenge with the existing, they don't want to. What's going well? Why disturb it? Okay. So they come to us when they see a challenge, and the awareness is taking its own course of time. So
Right.
that's the biggest challenge which we have currently. So we all are working towards creating an awareness. But thanks to the growing heat which is happening in AA environment and the HPC environment, it's becoming easier for us now to have this conversation with our customers. So first thing is acceptance in terms of, okay, we can look at this very seriously. So once that happens, then things become easier for us.
Thank you very much. I got the answer you have written down in the chat box, hydrofluorine as a refrigerant. Thank you very much for that. Coming to Mr. Vishal, you talked about changing heat density and also presented some AI survey of growth of data center by 2027. So how does liquid cooling compare to the traditional air cooling in terms of energy efficiency? Mr. Vishal.
Yes. So yes, of course, that is going to be energy efficient because the basic thing which we are changing is changing the media from air to water, which has a higher capacity to carry the heat. So this is of course going to be improved heat transfer efficiency, which any dielectric or liquid or hydrocarbon, as Mr. Amod said, will have higher capacity than the air. So that's one aspect. Um, Dielectric or water-based coolants can absorb and transfer heat directly from heat exchanger. So whatever heat is being generated inside the data hall or inside the server, they are directly. So it's not that the basic conduction, convection, radiation, and those things are applicable in air cooled, but in water cooled they are directly being transferred to the central distribution unit. So that's one area where the media itself is efficient enough. Second, as both the gentlemen said about the reducing the fans in terms of liquid cooling, and Amod was emphasizing on that, because in immersion cooling there won't be any fan, so there is a straightaway energy efficiency that they can generate, or that we can save. Third aspect, which I think is rack density, because it's liquid cooling. So now we are going away from 5 kilowatt or 10 kilowatt directly to 40 kilowatts or so, and the rack density itself will have higher heat dissipation from system, which of course air cannot do, and water or liquid is the only answer for this. So that will also be taken care. So higher rack densities will help in bringing the energy efficiency. um, Lower water and energy usage is other thing which I see, because the same as Mr. Amod was also referring to, that they are using the high efficient coolant near the servers and then exchanging it to more affordable thing which is available, which is water, and they're exchanging that heat with the water. So that also brings the efficiency. So majorly media and some components of the liquid cooling will definitely contribute into higher energy efficiency, according to me, in coming years.
Yes, thank you very much for sharing your views, Mr. Vishal. So there appears to be not one cooling strategy which can keep the heat away. So, Mr. Vijay, what cooling strategies should be implemented to optimize the energy efficiency of data centers?
It's a good question. One of the things we should look at primarily is to see how do we optimize the existing infrastructure itself. Like Amor spoke beautifully about retrofit. There is a mind block saying we can't retrofit liquid cooling in existing infra. It's not a fact. They can retrofit in the existing infra and optimize the existing infra instead of investing new on real estate and so many other capex. They can use the existing infra and retrofit and take forward, irrespective of whichever way of liquid cooling. Could be immersion, could be anything else, could be direct to chip, single phase, dual phase. They can leverage the technology which is already available in retrofit. That's the first step their data centers can take. And secondly, what they can also seriously look is how do we densify the rack? So a lot of times they're going for the safer bet instead of actually trying. So when they actually try, they can actually get a better ROI than what they're getting currently.
Good. While you talk about the ROI, Mr. Amod, what are the operational cost savings associated with transitioning to liquid cooling?
So very clearly, most of the liquid cooling technologies which are available today as options for customers, all of them have a lower OPEX than an air-cooled system, because all of them are using mediums of cooling which are very high thermal conductivity and much more denser in many cases as compared to the air. So from that concept itself, physics helps us that you will need lesser energy spent on getting the heat out. So from that perspective, what we are very clearly seeing that there is a range of saving that comes in the moment we look at operating expenses of data centers. The second is about capital expenditure as well. So there are technologies where the component count becomes smaller. The sizing of IT itself becomes smaller. To give you an example from liquid immersion cooling single phase, If I have a 1 megawatt data center, and just for simplicity, I am saying it is just only servers. It's not hybrid. There is no networking. There is no storage. 1 megawatt of servers. If I design a air-cooled data center, it will be with a good PUE of 1.5 on an average in our subtropical climate. So in the summer, it will be as bad as 2.0. So when I am designing a data center for a 1 megawatt IT load as an air-cooled data center in India, the design PUE is 2.0, which means my substation has to be a 2 megawatt substation. My DG set has to be 2 megawatt. My UPS has to be 1 megawatt, right? Now, if the same 1 megawatt becomes a single phase liquid immersion cooled data center, 15% fan consumption goes away. So now it is the same IT hardware is a 850 kilowatt IT hardware. Now this I will operate with a summer PUE of 1.2, which means now my total power consumption peak is going to be 1.25 megawatt as compared to 2 megawatt. So my transformer can become smaller, my DG set will become smaller, my UPS will become smaller, my number of batteries for the UPS will become lesser. So you start getting a capital expenditure saving in the design itself if it is a green field. Now this is the most extreme because in liquid immersion cooling, all the fans go away, right? But if you look at something else like a direct liquid to chip, there also the fan dependency becomes very low because almost 70 to 90% heat goes away directly in the liquid cooling. You only need 10%. So there also you will see that as a calculation, your capital expenditure or sizing of components definitely becomes smaller. And that will give you a good opportunity for reducing your capital expenditure also. Operating expenditure, definitely all liquid cooling will be better than air. Now the choice is how much you are able to eliminate the refrigeration cycle. That becomes the key from a competitive advantage perspective, because it is possible to have a chiller-based design also, which is again going to be very, very efficient as compared to an equivalent air-cooled design. But if you have a chiller-free design, it becomes even more efficient from an energy consumption perspective because the compressor power consumption completely vanishes. So like this, we are seeing that now the interesting part in the data center industry today is there are so many technology options. And in a country like India, there are so many diverse climatic conditions, right? And so there are very unique technologies which can be experimented on depending on the regional characteristics also, because some technology will be very good in hot, humid climate like Mumbai or Chennai. But if you have very cold winters in the north, maybe a different technology can give a better efficiency and so on. So it is really a very interesting field today where we can look at various options and trade-offs and then come at a more efficient way of operating a data center. But the fact is, liquid cooling is not because of efficiency, right? So being very candid here, performance is driving adoption of liquid cooling, not efficiency. Because what is the primary objective of a data center owner? He wants good performance for the IT that he is investing in, correct? So when customers started putting single phase liquid immersion as an example for high performance computing, one of the reasons they were doing it is because this technology was able to allow them to overclock their servers, which means you have a 3 gigahertz CPU, but you can operate it in the turbo mode like a 4 gigahertz CPU continuously, which is a big performance boost, correct? When I'm saying that a particular technology reduces thermal stress, so your semiconductor failure rate comes down, it means what? Your uptime becomes better. So most of the drivers that are actually going to drive the adoption of liquid cooling is not efficiency driven, they are performance driven, and so they are more critical, right? So for example, today, when you look at most of the new AI servers which are being launched, one of the popular architecture is a rack scale kind of a design, correct? Now, why would an IT OEM say that don't buy a small server from me and then you configure the cluster? I will configure the whole cluster, even deploy the cooling, and then you just put it on your site and operate. Why are they saying? They are not saying because they want to save you energy. They are saying because the performance of their cluster becomes better when they deploy it scientifically the way they have designed it. So from that perspective, I am of the opinion that the adoption of the cooling, liquid cooling, will be driven more by performance metrics. The side
Right.
benefit is efficiency.
Right. Performance and the size is going to be what matters. So very quickly, lastly, I want what future advancement is expected in data center industry. Very quick lines. Starting with Mr. Vijay.
What future advancement is going to be more power, more space for AI, and more for people getting to use AI. I mean, the use case of AI is still under a lot of research. Okay, a lot of
Correct.
people day to day, people have started to use AI. There are some people who are still worried about, do I see an actual business case? People have to see the business case coming in. So there'll be a lot of focus on, machine learning and all the LLMs where they want to see the actual usage. Like today we can handpick about one servam.ai, handpick a couple of them. Nothing comes top of the mind saying, you know what, I use the AI. Ignore ChatGPT is used just for knowledge. We use it as a glorified Google. Okay. So
Correct.
the actual AI business case in the healthcare, in the education, in the manufacturing, in the banking system, very importantly, and in the high performance trading, when we start seeing AI come in, I think data centers will have much more work to do. A lot of capex are getting pumped with the hope that the business case will be created by someone, but the actual usage, I think we still have a probably a couple of quarters or maybe close to a year to see how you and I as an individual be impacted. Like if I can again use Vishal's example, we still don't see Swiggy and Zomato use AI. They don't tell us what to eat, when to eat. We still have to choose. Okay, so we have to see where we are going to see AI in our day-to-day life in education primarily. Today, people are learning to write AI. We don't have to learn to write AI. We have to learn to create AI tools. Okay, I think we matlab not India, globally too, and let's see where this is taking us as a planet, and then the data centers will provide you the power and the energy to bring it. One thing is with AI coming in, the world is becoming much more smaller. Like I was talking to somebody in the Middle East, they want to create an impact of 10 billion Americans across the world, create an impact, not the actual population. So that's what they want to create their AI for. They want to have emeritus everywhere in the world in the virtual form. So it's all nice numbers, 10 billion, 1 gigawatt, 2 gigawatt DC is great to hear. We want to see how much actually goes live and see how much we can optimize there with the liquid cooling.
Very nicely said. Mr. Vishal, your quick answer.
Yes. So nothing different than what others have said, but yeah, it's the same thing that how people start using this. So there are look at from a business's perspective. If you look at Google, they have invented Gemini. If you look at Microsoft, they have Copilot. If you look at so everyone are coming up with their own AI tool, which requires a highly computing capability. So these are at the development or people like you and me are looking at, but at the back end where people like Nvidia and these guys where they are designing the GPUs, those are also supporting the entire growth. I was
Yes.
I was told by somebody that there is an app where or there's a AI tool where you can write a song and tell the platform that in which tone you want to listen to the song. So there is nothing which is so that there is no cap to the thinking. One can think anything and create a platform and tool.
Yeah.
There's
With
a
new
highly
technology,
computing.
yeah. With new technology, things will be developing. Last, quickly,
Just
your view,
quick,
Mr. Amod.
yeah. So, three trends is what I'm seeing.
Right.
First trend is all future data centers definitely will be liquid cooled data centers. The second is I am seeing a lot of interest and adoption, which is moving not only to hyperscale data centers, but also far edge data centers. Because today, the technologies which used to be hyperscale technologies like AI, there are applications coming up where a far edge also needs the same technology and hence the same chipsets and hence the same kind of a cooling challenges. So we are already hearing from customers applications which are less than 10 kilowatt, less than 20 kilowatt, where they need liquid cooling, multi-site. And the third is the kind of capacity of power that is being talked about in data centers, I am sure we will see more creative sources of power as a trend. For example, to give you 20 years back, a 10 megawatt data center in India was a very big data center. Today, there are customers who are telling me they are planning a 600 megawatt data center. Right. So from that perspective, now, do they really tap onto a grid or do they create their own captive power plant becomes the question. And so these are the three trends which I think will be very interesting to see.
Thank you very much, gentlemen. We had a very nice discussion and not many things were explored.